Hey, thanks for checking out Next Level Carpentry. I've had a pretty busy week with an ongoing remodel project on my day job, but I'm excited to show you this episode of the pallet wood door project. I'll pick up where episode 2 left off with those pieces of perfect pallets milled straight and true, and then show you the advanced millwork techniques that I use to make a very unique exterior style door jamb like this. Since my design has interlocking casing, there's extra joinery in this piece, and although this is fairly complicated, the steps are straightforward. So let's go to work. For this offset glue up process to work and avoid the predicament I got into gluing up this head jamb, I need to have a number of conditions in place. I've got the grain matched up for the two jambs. This is the hinge jamb, this is the strike jamb. And when I've got multiple pieces to orient, I use two lines on one side of the triangle so that I don't get this piece mixed up with that piece. But this is exactly how I want these pieces matched up and paired up when I glue them. And I draw in a rough mark on the ends so that I know which edge and which face of these pieces get rabbeted for this glue up. And to save aggravation later, I want to make sure that the face here and the face here have their finish milling on them, which means a final pass over the jointer here at a slow speed for a smooth finish. And I've made sure that these pieces have been run through the thickness planer so that I won't have any sanding or scraping to do after the glue up. So after making final decisions as to which edges go where and which faces are which, I'll run the mating edges for the glue up over the jointer to make sure they're dead square, straight, and smooth. A couple sidebar notes here for this final joining process. I'm using a very slow feed rate to make sure that the edges are smooth and require minimal sanding later. Also, make sure the infeed table is clean between each pass, because sawdust under the piece as it goes through can put a bow in the edge of the piece after final planing. Last but equally important is to make sure that the section of the cutter head I'm using for this planing operation doesn't have any nicks in it. It's been a while since I rotated the cutters on my helical cutter head, and if there was a nick in one of the blades that affected one of the edges, the resulting lump in the wood would throw off the glue up process. That's a subtle thing, but you'll see what I mean if you have that condition. With those final passes made to these edges, you can see that the fit up here is watertight, and I could glue it up now. But to make sure the offset step in here is precisely 3/4 of an inch, I've got one little trick up my sleeve to make it not only easier, but more accurate. Of course, this could be done with biscuit joints, dominoes, or some other method for alignment, but I want to show how I use a small rabbet to get the same result with less fuss and have the added benefit of concealing the glue line. Setting up this rabbet is stupid simple. I put a mark on the board that needs to be rabbeted that will end up with a 3/4 inch step in the face of the jamb. Because the jambs are different thicknesses, the rabbet setting will be different for each of the jambs. But I use this mark for the blade height and make the rabbet a 1/16 of an inch deep. And it doesn't even have to be an exact 1/16. And you can always run the rabbet a little shallow on the first pass just to make sure it ends up where you want it to. This piece is 3 1/16 wide, so I'll set the rib fence at 3 inches for a 1/16 inch deep rabbet. I'll do a quick test run of the rabbet on the first 6 inches of board. Now that I've confirmed the rabbet is a 1/16 of an inch deep and we'll leave a 3/4 inch offset in the jamb, I'll run the rabbet the whole length of the piece and then reset the blade height and run the other jamb. And it just takes a minute to run those indexing rabbets on the edges of 2 of the jamb parts. And now the glue up goes extremely well, and you can see here how that quick, simple rabbet indexes the parts for alignment during glue up. Plus the glue joint is actually a 1/16 inch back from this face and will be nearly invisible in the final assembly, especially since the weather strip fits into this corner. But I use the same process for glue ups like this when there's no weather strip to disguise the joint. As long as I've done my homework right with accurate milling and proper planning, this glue up is pretty painless. All the measuring's already done, I just need to put it together. I've got my orientation marks here to make sure I get the right faces and the right edges put together. And that rabbet works like a charm for alignment. Titebond's too busy sponsoring other channels to pay attention to Next Level Carpentry, but I still use their glue because I think it's the best for this kind of application. I'm using Titebond 3 because it's a little thinner than Titebond 2. I'm just using the slotted glue applicator tip that comes on the Tight Bond bottle. I'm putting a small bead right here up next to the rabbet, all the way along, and then I'll lay down 2 thin flat beads along the face of the rabbet. Notice I'm not using any special aftermarket applicator tips, any fancy rollers or anything. There was a little dried glue on that tip and it didn't lay the bead down just like I like it, but we'll see how this does. I lay the piece down there, work it around a little bit. And I'm getting real good glue distribution just with hand pressure. The rest of this will fill in when I put the clamps to it, but I'll throw another little bead in there just in case, but that'll just result in extra squeeze out when I clamp this up. These pieces are just rough cut to length, so I don't have to worry about the ends lining up just now. And I'll throw a temporary squeeze clamp on here just to kind of keep things lined up as I go for the bigger clamps. The concept of gluing things up on edge instead of laying flat is somewhat unique to Next Level Carpentry, but I find the process so much less messy and quicker, so I use it whenever I can. I like to start clamping somewhere near the middle, and I pull the piece tight to that rabbet as I go. I've got this deep reach clamp that I can use to pull these faces together if it won't pull together on its own. I stagger the clamps from front to back, and that helps even out the glue up so I don't get a hinging action. But as long as the rabbet is true and the edge of this wood is square, it pretty much self-aligns. With thick wood like this, I don't have to space the clamps that close. And I'm feeling on the back side for the same margin all the way along. This piece is about a 1/64 of an inch thicker than it needs to be. And as long as that margin stays on the back, I know that this is that it's tight in the rabbet. And notice I don't put this clamp too close to the end. That'll just over pinch it. So I bring it in, 6 inches or so. But I'm getting nice even squeeze out with the glue. And I don't know if you can see this, but there's good squeeze out on the back. And I've got an even margin all the way along. You can see the glue joint is watertight and precisely a 3/4 inch step from the one face to the other. And anybody that watches many Next Level Carpentry videos knows what's next. I've got the bucket of sawdust, aka Geigler, which is just fine sawdust from the miter box or from cutting particle board. And I just use that fine sawdust to wipe up this glue. And it doesn't take much to pull the moisture out of that glue. The glue's skinned over a little bit because I'm talking for the video, but basically, once I've thrown some sawdust in there, I just take a sharpened putty knife and clean that joint out. And I think you'll agree that's tough to beat for speed and effectiveness. And you can see how that fine sawdust turns that glue into like a putty, a lot less messy, and it doesn't smear around on the wood. And the advantage of using a wide putty knife for a thing like this is that this is an acute corner here, so that I can easily scrape one face and then the other, and that sharp corner gets right down in to the very corner of that rabbet for an effortless and perfect cleanup of glue squeeze out. And if there's a downside to edge gluing, this is it. I need to move this piece with all these clamps sticking out over onto a horizontal surface so I can scrape the glue off the back. And it can be a bit awkward and gangly, but it's a small price to pay for the effectiveness and efficiency of this glue up process. This is the extra glue squeeze out I got because I added that extra bead of glue, but as long as I've got 100% squeeze out along that joint, I know I'm never going to have a dry, ineffective glue joint. And it's just as easy to clean up a lot of glue as a little with this method. And the only real difficulty here is that I can't stand right where the camera is to get a better angle for scraping this glue. Now I always like to verify that everything glued up like it should. And you can see here that this is perfectly flat on the back when I check it with this little 12-inch rule. And I always like to throw a quick timestamp on a glue up, so I know how long it's been in the clamps, which tells me when I can remove the clamps to continue the milling process. And these two pieces are nearly perfect for flush, but remember I left extra thickness on here so I can run this through the thickness planer to make it perfectly flat by using that simple stepped platen in the thickness planer. And that sequence there is pretty much what a good glue up goes like. Everything's planned ahead, dry fit, all my tools are ready, I know the joinery is accurate, and things go well. But glue up can be a pretty stressful part of a project. Things don't always go quite so well. And I want viewers to know that I had some difficulty gluing up the other jamb. I had everything in place, I had the camera rolling, and lost my focus on the project because of the video, and I actually glued the stepped piece of the jamb on backwards. There was some trouble with the glue up. I should have known that things weren't going well, the glue didn't spread out well, and I didn't catch it until I was scraping the glue off the back and I noticed my alignment marks weren't lined up, even after I made a point of calling out the alignment marks and the need to pay attention. But it just reaffirms the lesson to pay attention to reference marks in the heat of battle, because that kind of detail can slip by unnoticed and generally causes a lot bigger problem than this. So I'm just going through this dialogue so the viewers know, yeah, stuff happens. This is a complicated process. There's a lot of moving parts, a lot of things to have to happen in the right order, and everything has to go well. And despite years of experience, my best efforts, a small distraction like running a video camera, I lost my focus and had some troubles. I was able to pull the thing apart. You remember I have extra width in this shelf piece here, so I was able to replane the edge off, get everything fit up again so it'd go together smoothly. So that's why I like to have that margin of error dimension put into the wood as long as I can. This face and this face are done, but like I said, I'm going to run this through and true up that back face to take off. It's about a 1/16 of an inch extra. I can use that 1/16 of an inch extra if I have other issues that I got to plane out and mill out. So it's always nice to have a built-in insurance or buffer zone in the process. That helps take some stress out of the glue up, because if I've got a one-time all-in shot at the glue up and something goes wrong, I got to start over, and I don't like that. So as long as I have extra material, I try to build that extra cushion into the project. So this big jamb is glued up. I've got to re-glue the other one now that I've kind of corrected for the difficulties, and I'll have to pay attention this time to get it right. And I'll come back once I've got both of these glued up and the glue is dry. Bottom line, you run into difficulties, figure a way out, push forward, and don't let the discouragement keep you away from woodworking. Hey, it happens to the best of us. I talked to a guy once that was really good. That's what he told me. You know, if you like the kind of in-depth detail you're seeing in this video, you should consider subscribing to Next Level Carpentry if you haven't already. It's free, and as a subscriber, every time a new video with content like this is uploaded, you'll get a notification. Recently, subscribers have been able to join in when new video uploads are released as YouTube premieres. They're able to join in the discussion and have a live chat with other viewers. I've been able to join in that chat session that runs alongside the video and enjoy the banter. So I hope you get to check that out, because I look forward to it for sure. I left this hinge jamb in the clamps overnight, although a couple hours is plenty for a glue up like this. I made this clamp storage rack some time back, and the more I use it, the more I like it. Clamps store securely, and it's quick and easy to deploy them and then park them back in the rack. And I actually even have room for a few more clamps. Imagine that, a woodworker without enough clamps. With the glue up complete, I'll continue with the dadoing and rabbeting steps so that these jambs end up looking like this. The important part is, at the completion of glue up, the rabbeted faces, flat and the vertical, are perfectly true and smooth. I don't need to do anything else to those. And the sides are all parallel. So when I need to change the width of these different jamb sections, I can just index off a parallel edge. Once I cut it down and plane it to the final width, I'll do the dados that accept the casing like this. And I can flip one jamb over to nest it with the other one to demonstrate the consistency and precision of this milling and glue up process. Doing mill work in general, and specifically on these door jambs, consistency is of the utmost importance. I'm making these three pieces individually with the same setup, but then I'm going to cut the corners and put them together, so everything has to be the same dimension to line up for the final frame to function the way it needs to. Because of the difficulty I had gluing up this strike side jamb, the width of the rabbeted lip on these three jamb legs is slightly different, but this shoulder lug or the integral doorstop, those are all consistent width. So I'll use the edge here to index all the cuts and dados that go into the jambs from this point forward. I made a couple of dimensional design adjustments from this original prototype jamb to what I'm going to cut for the actual finished jambs. On this prototype, I've got a 3/8 inch dado to accept a 3/8 inch tongue on the casing, but I want to reduce the amount this jamb edge protrudes past the face of the door. Here I've got 5/8 of an inch because I've got a 3/8 dado and a 1/4 inch lug, but that is unnecessary. This tongue will function fine at a 1/4 inch, and I can reduce this projection by a full 1/8 of an inch. So this is the final layout that I'm shooting for. This is the head jamb, and I put the markings on here. This integral doorstop lug on all three jamb pieces is the same width, so I'm indexing off this back face like I said, but the dimensions are 3/8 of an inch here for the weather strip when it's compressed. This little slot I've yet to put in there, that takes the barb for the weather strip, but I've got 3/8 for the weather strip here, 1 3/4 for the door. The face of the door will be in the same plane as the face of the sheetrock on the wall, which will be here. Then this 1/4 by 1/4 dado is for the tongue of the casing, and then this surface here will be the face of the jamb. I want to establish the two edges of the jamb first, so I'll make this cut a 1/16 of an inch proud, indexing off the back face, that way I can joint this face, and then rip this face a 1/16 of an inch proud and plane it so that I end up with a jamb that's 5 9/16 wide from face to face. I guess I forgot to mention that I'm allowing 4 9/16 inches for the wall thickness. That's a 2x4 wall with 1/2 inch sheetrock on both sides, plus a 1/16 inch fudge factor to make this work out. And I'll make a note here, but it'll probably come up again later. Because the door casing fits into a rabbet or a dado on the back of the jamb, I've got very little margin of error for variance in wall thickness or the wall being out of plane. In a regular door jamb that's just flat on the front, the casing can be pivoted and rocked to account for difficulties in the wall itself and the sheetrock and how it was framed. But this jamb design will only work in a wall that's as close to perfectly plumb as possible. Remember that I built extra thickness into these jambs so that I could plane the back smooth and flat at this stage of the build. This strike jamb is the thinner one. I've got a lip in the back here because of replaning after I had difficulties with the glue up. Ultimately though, I need to end up with a show face here that's exactly 3/4 of an inch, which I'll get by planing about a 64th here and about 3/64 here. Ultimately, this hinge jamb will end up with a 3/4 inch show face, but because of the extra thickness, there's more steps involved in getting that. But that 3/4 inch lip on all three jamb pieces is important because that's an exposed edge of the jamb for this design. Regular flat interior jambs, a variance in thickness wouldn't make a difference because the casing covers all but a predetermined reveal. So I'll use the planer platen I built earlier to true up the long legs of the jamb. And if you like the way this outfeed roller looks and works when used in conjunction with the thickness planer, I'm hoping that if this episode build video format goes well, that the long-awaited build video for those roller stands is next in the queue. Cleaning up the back of this strike door jamb for a nice smooth surface was way too close for comfort. So I'm quite thrilled that I ended up with an exact 3/4 of an inch and a clean jamb back at the same time. Now I can move forward with ripping these jambs to width. I'm careful to use the same setup for all three jamb pieces for each edge that I'm cutting. Indexing off the thick edge, I rip the thin edge and then clean it up with a slow, steady pass over the joiner. Once that's done, I flip the pieces edge for edge and repeat the process with a different setting on the thick edge of the jambs. It's always reassuring to kind of get to this stage of a project. As each step builds, a mistake means a bigger redo process. So I always feel a bit of stress release getting to each stage of a project like this. And now all three of these pieces have identical face properties, the width and step distance. So now I can transition to the process of putting these rabbets in that'll accept the casing. I'll start on the thick edge and make a large rabbet here so that I end up with exactly 3/4 inch for the show face on the edge of the jambs. Having one jamb leg that's extra thick for those concealed hinges complicates this setup a little bit, but as long as I index off the face, these rabbets and dado will be the same on both legs and the head. This layout isn't accurate, it's just so that I remember what goes where. On the 3/4 inch edge of these two pieces, that dado is a one-shot deal, but I've first got to notch this big jamb so that the face ends up 3/4 of an inch here. But I'm going to set up and do this rabbet first. I always flip the pieces to orient them so that the indexing face is in the same orientation for each piece. This way, the indexing face here will automatically be up against the fence each time after I make the initial setup. The layout on this end of the head jamb are precise, so I use those for my saw setup, and I'll make a cut here first. It'll be just deep enough so that it doesn't cut past this line. And I lock the blade height at about a 1/16 lower than that pencil mark. And naturally, I set the fence at 3/4 of an inch plus a frog's hair. That extra frog's hair is because after I make this cut, I'm not able to plane that cut edge on the joiner, but either way, I need a little extra thickness to remove the saw marks because that will be a finished visible surface when this is done. You'll see that step a little later. I have to make a unique setup for making this initial cut in the thick edge of the thick jamb so that I end up with 3/4 of an inch. But I'm doing it now because the blade depth setup is the same as the cuts I just made. Because of the shape of this jamb, I actually have to index this cut off the back of the jamb instead of the front like the other cuts. No big deal, but I just have to pay attention. And I'm leaving an extra frog's hair on this cut also. There seems to be a passionate contingent among viewers that wearing gloves in a workshop is extremely unsafe and foolhardy. In some measure, I agree with them, but for operations like this, I want my safety factor to be the grip I have on the workpiece. And in general, anytime your hands are close enough to a spinning power tool to engage a glove that you're wearing, you probably need to adjust your workflow somewhat already. I'm shooting for a finished 3/4 of an inch. And that will do nicely with an extra frog's hair for planing to clean up the sawtooth marks. Because of the unique nature of these rabbets and dados on this particular jamb, the steps I'm using here are arguably unconventional. I'm going to begin the dado process as I relieve this piece of wood in the rabbet here by setting the saw blade to cut up into that dado already, but make a clean swipe at this edge. That just eases the job of the dado blade later when I'm plowing out the rest of that dado. The edge made with this cut won't be seen after the casing's installed, so I'm making the cut right to the pencil mark because I don't need to clean it up afterwards. And I'm careful to pinch and grab the off-cut piece as it comes past the backside of the table so it doesn't become a projectile and harpoon my toolbox. I have to make depth setting adjustments for cutting the thick jamb, but other than that, finishing up the rabbet is the same process. The rip fence setting remains the same, it's just the height of the blade changes. And naturally, the size of the offcut is bigger. I'm switching to the Forest Dado King dado blade set to plow the dados in these jamb edges. I'll switch out the throat plate here to one that I have that's set up for 1/4 inch dados. And FYI, people always ask about this blade insert. It's a Wood Dynamics insert. It's a fantastic piece, but unfortunately they don't make it anymore. You can view information that I have in this photo that shows the company and the patent to search these out in case you can find one on eBay or Craigslist. I suspect that they quit making them because it doesn't have a slot for a riving knife, and maybe that's a deal breaker. The Forest Dado King is set up to cut dados slightly undersized for certain sheet goods that are smaller than a fractional equivalent. And for a 1/4 inch dado, I just need the two outside blades and add 20 thousandths of an inch to end up exactly at 1/4 inch. Notice I used this sheet of rubber with a hole punched in it to protect the carbide teeth on these two blades from chipping. And I'll add 1 shim of 20 thousandths to get this done. And I always like to run and measure a sample cut just to make sure I did my math right. The width is spot on, the fence is spot on, so all I need to do is set the depth as I plow these dados. And I'll do the straightforward easy one first, which is in the thin edge of the head and strike side jambs. And you can see these custom roller stands in action again here, which I hope entices you to stick around when I do the build video to show how these are made and how they work. After changing the blade height, ripping the same dado on the thicker jamb is routine. And yeah, I know, this is getting boring. After that last dado on the last edge, I've got the real jambs matching the prototype with those slight design adjustments. And this jamb is 1 step away from being ready to cut the corners for assembly. If you've been with me the whole time, you'll remember that there's 1 more slot that needs to be plowed in here. And that slot accepts this barb on this weather strip. The barb slips into that slot and then compresses when the door gets closed. This is an excellent type of weather strip. It's easy to use, it's easy to set up, and it does a fantastic job of sealing. And to the uninitiated, that's a simple thing, right? You need to make a 1/16 inch slot, get a router and a slot cutter, make a slot, right? Wrong. If you think about it at all, you realize that slot cutters come with the bearing on the bottom. I can put a 1/16 of an inch slot cutter in there, but the bearing and the arbor nut definitely keep me from getting that slot down close enough into this corner. And another natural approach to this slot cutting situation is to use a saw blade. Get a thin curved saw blade and run it in there and make that slot, right? Wrong again. The distance from the edge of this particular jamb, because I have this extra material on here, mean that once the arbor nut and washer are on a 7 1/4 inch thin curved saw blade, I can't get the depth of cut that I need to make a 1/2 inch or 3/8 inch slot, a 1/16 inch deep. I might be able to find a 10 inch blade with that thin of a kerf, a 1/16 of an inch, but if any blade fluctuation is going to make chatter marks in the face of this jamb, and that's not acceptable. I was a bit dismayed to go and look all over the internet to find a slot cutting bit to do this. The closest thing I can come up with is some bottom cutting bits, but the narrowest slot they make is 1/8 of an inch. A lot of the woodworking forums talk about using the saw blade method and putting like a 3-degree tilt on the blade to keep it from making chatter in the face of this jamb. A couple years ago, I made some exterior commercial doors out of solid white oak. This is a sample of that jamb. And because it's a traditional jamb without the extra material on the corner, like this that I'm using for the casing, the trim on this door just fit right on the face of the jamb. And with that setup, a 7 1/4 inch thin curved saw blade was enough to reach up in there because the arbor nut didn't hit the edge of the jamb while making the cut. I did put like a 2-degree angle on it just to make sure I didn't get chatter on the face of the jamb. And I really enjoy a challenge like this. I've got to do something outside the box. I got myself into a predicament because I made extra width on the jamb. I didn't know at the time that I was going to have this trouble with the slot. I assumed that I could just go out and get a router bit, or failing that, I could use a saw blade. Both of those didn't work. But with most situations like this, there is a way out. It just takes some creative thinking. And that led me to a CMT router bit for the solution. And this is the CMT router bit that I found that solved the problem. This is an arbor. Here's the number 824.061.10. And after this little session, you and I know more about this router bit than CMT does. It has a countersink flathead screw in the bottom, and it's made to accept their CMT slot cutters that have a 5/16 arbor hole. And what I found out that they couldn't tell me when I called tech support is if a 1/16 inch slot cutter would work on this arbor. If you shop this arbor online and look for cutters to go with it, they have a 5/16 hole, but they have a small 45-degree countersink in the middle. That mates up with the 45-degree angle on the bottom of the screw, and there's a 45-degree recess in the bottom of that arbor. I hope you can see all that. But when you put this together, you can see how those angles will cinch together. But the thinnest cutter that they sell with that 45-degree modification to the center, I believe, is 1/8 of an inch. So that wasn't any better for me than the bottom cutting bits sold by others. But as a carpenter, 45 years of dealing with reality, I just went out on a limb, bought the arbor, and just decided to try it out with the slot cutter I already had. There's a 5/16 arbor hole in this CMT 1/16 inch slot cutting bit, and there's no problem with it holding down. I suspect the reason that the engineers at CMT don't recommend this is if that arbor nut is improperly tensioned, it could probably bend the plate of this slot cutting bit, make the teeth wobble, and be unsafe for their users. So it's probably the legal department that keeps the technical department from knowing or understanding what I discovered here. And I think you can see at this camera angle that there's the slightest bit of clearance underneath those teeth when that arbor nut is touching the surface. And that's pretty good the way it is, but I don't want to get burn marks from that arbor screw when I use the very close setting that I need or that I want for making this slot. So I'll make a very small modification to this 16th inch slot cutter. And I'll note the bottom of the cutter and the direction of rotation so that I countersink the right face and don't end up using the bit spinning backwards. And make note that neither CMT nor NLC recommend doing this at home if you're not comfortable with what's going on. If I weaken the plate by countersinking it and it should come loose during the slotting operation, I'm going to have a 10,000 RPM Ninja Star flying through the shop. And if that hits anything, it ain't going to be pretty. I've got aluminum jaw protectors in this vise, so I'm okay with clamping carbide with enough pressure to hold the piece without chipping it. And I'm just using a high-speed steel countersink bit to see if I can ream the square shoulder off that hole. I want to leave the slightest amount of square shoulder from that hole so that I don't take that countersink all the way through and have a sharp, weak edge on the other side of the cutter. And I think this will do pretty nicely. I don't want to make that so tight that it distorts that bit plate. But I think taking just a little bit of that square shoulder off this face of the cutter is going to do the job perfectly. And I think you can see here that I've reduced the interference of that clearance nut to about a 32nd of an inch on the face of those little cutters. So now I can get this slot cutter right down close to the face of that jamb so the weather stripping fits nice without spoiling the jamb in the process. To further confirm the change, you can see in this shot that that steel ruler won't fit between the table and the teeth anymore. I think if I needed to get any closer than that, I could probably take a few more thousandths out of that arbor hole with the countersink bit and get this down to nothing. But that would further weaken the arbor plate, and the tolerance I need for this job isn't so tight that it requires it. And maybe I should apologize to viewers for dragging you so far into the weeds over something as simple as a slot cutting router bit. I guess I'm still a bit bewildered that out of all the thousands of customized router bits that are out there, nobody makes a bottom cutting 16th inch slot cutting bit. If you check online, they've got all this weather stripping and they got some funky looking tool that goes in an angle, but it kind of churns up the wood making a slot when it's just so stupid simple. Make a bottom cutting router bit and cut a slot. Jeez. Anyways, I just need to chuck this up in a router and get the job done and let you people get on with your life. It's a small slot cutter and there's not a lot of power required for making the slot, so a Bosch Colt router is perfect for the job. And despite all those steps and dialogue and thought, I could still screw this up. So I'm going to run this slot on my little sample jamb first and then double check the depth setting before I do the finished jambs. There's just the slightest bit of clearance between the arbor nut and the face of the jamb, and that should work great. All that for that? Good grief. And I double checked the depth setting on the finished jamb to make sure that any difference between the prototype and the final product doesn't cause problems. I got so carried away with all that slot cutting business that I almost forgot this part. I'm just taking my Stanley low angle block plane with a very sharp Hawk plane iron in there and using this shoulder of this deep dado, I'm just going to give a couple light passes to the edge of that cut to take the saw marks out of that. That way, when the finished casing's installed, no saw marks will show up in that little dado. Now this is the prototype casing with the 3/8 inch lip. I'm going to shrink that down to 1/4 inch so it fits in there, and then it'll leave a little 1/4 by 1/4 by 1/4 reveal slot in there, and with the milling process it'll be smooth on all 3 of those edges, just like it needs to be. Maybe we should measure this. Hey Chip, would you read this outro script while I finish routing this slot and these jambs? I'd really appreciate it. Thanks. Oh yeah, sure thing. This whole thing here? Yeah, no problem. Outro. I don't want this video to run too long or I won't get it published this week. So you need to come back for episode 4 to see the joinery, assembly, and installation and initial installation of this jamb, of that jamb. He'll also show mortise prep of the hinge jamb leg for these remarkable Sugatsuni concealed hinges. These must be the ones here. These babies are pretty slick. They're invisible when installed, and they also have 3-way adjustment in them, unlike sauce hinges for the same purpose. Pretty cool. If you've never seen or worked with sauce or Sugatsuni concealed hinges, you're in for a unique experience. Each new patron on this list from Patreon helps bring the possibility of making Next Level Carpentry, my day job, his day job, closer to reality. And so he really appreciates all of you who have gone above and beyond to make that happen. Thank you. You can buy official NLC t-shirts like this one, the one he's wearing, mugs and posters by clicking the link in the video description below. And you'll also find a link to a dedicated Amazon influencers page that he made for this video that shows all the stuff that's being used here, the tools and supplies. Stuff from that page is at the same low online price you expect, but Jeff Bezos of Amazon pays a small portion of their profit to this channel and helps make it a bit more viable as a business. So thank you. Plus, once in a while, he actually buys me lunch, which is pretty cool. Let's see, this must be next. Since I do very little with social media, it's great when any of you post comments on Insta, Google, Twitface on my behalf, or on his behalf, because it helps spread the word about this channel, which is a great and wonderful thing. Now that he's done and quit making all that racket over there, I'll say for both of us, for now, as always, thanks for watching. Did you know that there's different species of cardboard? Yeah, a lot of people don't know that. But this right here, this is boxwood.